Okay, I think we're live. So if you can hear me, please let me know in the chat. Anyone that's new here, everything goes through the chat and it's expected to be more like a conversation in that you should be using the chat to say yes, no, I don't understand, etc. Just so I'm getting constant feedback. Okay? Now, I've got 2 emails earlier before the live stream to ask us certain things to be covered. I'm going to start with recursion just because I don't know how many students will get up to that stage, and I imagine that more people will join as we go along. So I'm going to get that out of the way. Now, I did intentionally put this up on the screen because this is recursion. And recursion is basically when something calls itself over and over and over again. So you can see here, we get getting over and over again. So I just wanted to quickly cover, now I am being careful, and we are careful with how much we give away with the 3rd section, because this is truly a stage that tests the students that have the ability of logic and those that can code. And my pen seems to not be working. Okay, give me a second, something's working. What the hell is going on? Give me a second, something's not working. Let me try putting that back in. There we go. Now it's working. Cool. Okay, now it's not working. What is going on? Okay, the eraser's not working, but the pen's working. That's great. Just what I need. Right, does this button work? Okay, something weird's happened. Let me just want to check the settings for this. Wake up. Sorry about this. Okay, pen's working. That's not working. Okay, well, this will be interesting. Because not everything's working, but we'll go with it. I might try and fix it when we have a break, because it's also way too sensitive. Alright, so I might have a break early and fix this pen up because it's acting weird. So recursion is basically a function calling a function calling a function within itself. Okay, and that happens over and over again. Now, this can result in a big problem, which is infinite recursion, in that it calls itself over and over and over again. I keep forgetting this eraser. All right. So this is something that we want to avoid. I don't know what it's doing. Sorry, I'm really sorry about this. This pen is being stupid. All right. Okay. So with recursive functions in C, I can't even draw a straight line because of this sensitivity. We need some way to exit the recursive function. And generally this is going to be a condition, okay? So we need a condition to say stop the recursion. Okay. Now, this means that we need some kind of if in our recursive function. Now, when it returns a value, generally a recursive function will look something like this. So, give me a sec. This is really annoying. Just give me 5 minutes. I'm just going to try and fix this pen because it's impossible to draw. I'm really sorry about this. There we go. Let's see if that works now. There we go. Okay, everything's working now. Sorry about that. All right. So I might make this a bit more readable now that that's working. So there's 2 kind of ways we can go about this. If it returns something, so let's say I've got int func, int w. Okay, so one way for recursive functions to basically end is that generally we'll have an if or multiple ifs that call a function, but it won't just call a function, it will return a function. Okay. So it's returning the result of the function, and this might be a value, let's say w minus 1. Okay. Now, to end the function, we're using one that returns something. God, everything's just we'll return just a value at the end. And we saw this with the factorial. However, if we've got a void function, it can be slightly different. So with a void function, we can't return a function. So generally, what's going to happen is it's going to be an if, and then there's going to be a func somewhere, and then it'll just end if that condition isn't true or multiple conditions aren't true. Now, in our assignment, we have a board with 1s and 0s in it. Now, if there's lots of 0s, and we know that the board is revealed, okay, we can know to end the function if all the surroundings are revealed and not 0s. So once it looks at this one and we make it revealed, and we looked at this one and we make it revealed, there's nothing left for this function to do other than end. So when writing your recursive function, if you're doing it this way, there is other ways to do this. As I said, it can be done, this function can be done in about 8 to 10 lines or even less than that. But there has to be something around here that makes it not go to all of them once it's done. If it's still checking this and you never, let's say, set that to revealed, it's just going to keep going around in a circle. Does that make sense? So it needs some kind of escape. And you have enough that you don't need any more information to make an escape. Once these are all revealed and they're not zeros, that's done. Okay? So you can use the zeros and you can use the fact that they're revealed to know when to end. Because once everything's revealed around it, it doesn't need to go into that. Another thing, if this is revealed and it's a zero, do you need to go in there? No, it's already revealed. And that's why we've got this border as well, which the students that have finished worked out for themselves. So anyone still working on it and wasn't able to pick that up, that's that. Okay. All right, does that make sense? Kind of. Well, basically you should check, do I need to go into this function again when I get here? And maybe you need to do something beforehand or after to stop it going into calls multiple times. With pathfinding algorithms, if we have recursion here, and usually this is where you'll end up into a infinite recursion, is this one here is going to look at the surrounding ones. And so it calls this function. This one's also going to look at the surrounding ones. So it calls this one. Or it calls this one, and then this one calls this one, but this one also calls this one. So with the recursion, it should only be calling ones that it hasn't seen before. And you've got the ability to set these to revealed or not revealed to say if they've been seen before or not seen before. So you can use that to help. Okay, does that kind of help? Without giving too much away? Okay, so next question we had was absorb the knowledge. The next question we had was about the print function, but I might actually answer one of the questions in the chat first. Just incrementing and decrementing. So, because this is a fairly easy question. If we have a equals 10, to increment it, we just go a plus plus, or we could go a equals a plus 1, or we could go a plus equals 1. And that's incrementing a number. So incrementing just means adding 1. Decrementing a number can be done by a minus minus, a becomes a minus 1, or we have a minus equals 1. Does that answer your question, or is there something else to that. So you can increment and decrement quite a few ways. You can also go minus minus a, and you can also go plus plus a if you really want to. Does that answer incrementing and decrementing? Let's wait. Let's see if it does. So if you're joining us, please just say hi in the chat. Cool. Cool. So that answers that. Beautiful. Right. One other thing I wanted to talk about, which was a question that I got about the printing. Now, the printing is really important and it's very early on, and I want to make sure that you get that working because that allows you to debug the whole thing. So I'm not going to go through the assignments example. I'm going to go through a different example just to show what happens in each case. So I'm going to introduce an array. Okay, and this is going to be a 5 by 5 array. Okay, so this isn't dynamically allocated like yours, where yours will be, and also it will be struct location where this is an int. Okay, so it's slightly different. I'm trying to think what's the best way to do this. So I'm going to, what should I do? What I'm going to do is actually initialize this. Just, it's going to take a little bit. So we can initialize a two-dimensional array. You won't need this in the assignment, but it's good knowledge. So I'm going to go 1, 3, 4, 2, 1, 8, 3, 6, 2, 7. So as I said, you won't need to initialize yours in the assignment, so you won't be doing this part. I'm just doing this so to make an example. 2, 4, 1. 7, 1, 1, 1, 3. And then 2, 4, 6, 8, 9. Okay, so now I've got a 5 by 5 dimensional array. Okay, so not a two-dimensional array with 5 rows and 5 columns. Okay, now yours in the assignment is slightly different because you have that border region we talked about, but this is a good example. So I want to print this matrix out. So I can do this using a for loop. Now, we have sorry, I less than 5, I plus plus, and we have 4, I equals 0, I less than 5, I plus plus. Now obviously your array will be a n by n dimensional, but it's still following the same construct. I don't want to give away the answer, so that's why I'm using this example. So just be aware of that. But this is not the solution, this is just an example. So I want to print out each of the values, and I just made a huge mistake. So I do something like that. Okay. Now, oops, I really am losing it. All right. So we have that. Okay. Now, if I print this at this stage, it's just going to print 1, 3, 4, 2, 1, 8, 3, 6, 2, 7, all in a big row. Okay? And if we go through the loops, and when testing your assignment, you can do the same thing. So I equals 0, j equals 0. So it's going to go A, 0, 0, which would be the 1. So it'll print a 1. Then we go back up 1 in the for loop, we add 1, and we get a 1 here. And now it'll print 0, 1. So we'll print a 3 out. Then we'll go back up again with 2. We'll print 4 out, and so on. Okay, so you can follow how the loop executes. Now, if I just wanted to print so let's have a look at our matrix first. I might draw it up in matrix form. If I can draw a straight line. Three, 5, 5, 1, 3, 4, 2, 1, 8, 3, 6, 2, 7, 4, 2, 2, 4, 1, 7, 1, 1, 1, 3, 2, 4, 6, 8. Okay. So if I wanted to just print out this center section, what would I do? Well, firstly, at the moment we're printing it as a big line. So you'll notice that inside this loop, I'm printing 1, 3, 4, 2, 1, and I want to print a new line at the end. So it has to happen after this for loop. Okay. So printf new line. And most people would have seen this in the lab this week. Okay. So now it's going to print basically this. I might want to give some space as well. Now on the assignment sheet, it does tell you how much space to include. So be aware of that. Now, from that, if I just wanted to print out this middle section, what would I do? So I'm going to leave this for the chat. So what would I change? And if you're watching, please contribute. It will speed things up and it will also help me. So I just wanted to print 362, 224, 111. So we could change I to 1. We could change J to 1. We could change this to 4 and this to 4. Okay. And so similarly on our assignment, we start from 0 and we've got board size plus 2. No, board size plus 1, I think, as the top value. Yeah. So we can change this and subtract 1 to get just that smaller region. And so we print 362, 224, 111. Now, if I wanted everywhere there's a 2 to print the symbol, let's say, ampersand, what would I need to change? So every two, I need that. And actually, I might get this. So if I wanted to print for every two that's on the board, I want to print an ampersand. What would I change? So I'm going to give you a minute to answer that. Or just say don't know if you don't know. I might get this. Yeah, beautiful. So if everywhere there is a 2, we can just put an if statement in there. If A, I, J equals 2, else printf ampersand. Okay. Now that's a string, so just be aware of that. And we're kind of doing a similar thing, except for we're using bitwise, which we covered in last week's help stressor, to do these conditions in ours. So now it prints out this. Now, if I wanted to print, let's say, before every line, I wanted to print out the hash symbol, not hashtag, hash symbol, before each line, so I wanted it to be like this. Where would I put that? So if you're watching the stream, please use the chat. If you don't know, please say I don't know. It's expected that you contribute. Before the second for loop, exactly. So we can do a printf hash. Okay. And we might want to use some formatting to make it look nice. Now, if I wanted to put a hash above each one of these, where would that have to go? Yes. So someone brought it up. So if I wanted to print hashes at the top, I would need a separate loop. However, in this case, I don't even need a loop, but I'm going to do the loop anyway. Especially if it's unknown, we need another loop. So I'm going to create another for loop at the top. Now I also have this offset, which is here, so I'll probably need another printf as well, just to make that offset. And then I'll have a for loop, I equals 0, I less than 3, 4, sorry, I plus plus. And this is going to print some hashes. Now we can see already that this is looking very similar to our board. Obviously these are going to be numbers in our case, but it looks very similar. Okay, so we have a for loop before, we have a printf before our for loop, we have a new line after our for loop, we have the outer for loop, we have I and j, we have this little offset part. There'll be a little bit more formatting, but we pretty much have our print board function there. Now one thing with the assignment, so if we go to print board, blah, 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 blah. Now, actually I might do something else. Do that. I'm going to do that. And I might do this. I might do this. 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 Now, what do I do? Okay. All right, so you'll notice that it talks about the starting position, the ending position, that we ignore 0 and gain height +1, which we already talked about. We talked about just getting the center part. Now you'll notice that there's this if, else, if, else if, and else. And inside there, we have these. Now I didn't specify, I just used the indenting purely because if you understood the domain of the problem, you should understand why these need to be inside revealed. Because if it's revealed, then it shows 3 different things, else it would show this. So we can see that this is nested. Okay, so we have a nested for loop, if statement. And nested just means if, or, oops, that was bad. So if, else, and we can nest loops and not loops, conditions inside each other. And we can also nest loops inside each other, as we just saw. We just saw the double for loop, and we would have seen a triple for loop in this week's lab. And that's all nesting means. And so you can see the indentation is a nest. Okay. Now I've lost my chat. So we had another question, which is a logic question, which is actually a really good question. When the user selects a line on the board, should the board print out the line before the you lost message? And it's quite an easy question to answer by just looking at the flowchart. So we can see this part here is the game over, so is alive equal to 1, and that they haven't won. So we can see this is the case that they've actually won the game because all the flags are clicked. Now we get the move here, so if they click on a mine, that's going to happen here. So they select one with a mine, We check that it's uncovered. Obviously, if it's a mine, it can't be covered, and that it's not a flag. Okay. So we go into here. If it's not a flag, if the user hasn't decided to flag it, we go here. So we call this function, and then if it is a mine, we print the game out. Then we come back here, and now it will check, is the game over or not? So the answer, and then we print an appropriate message to the user. Okay? So we can see that indeed, that when you hit a mine, it should print before it checks to escape. Does that answer the question? Now, one other thing that I will mention while I'm on this page is if you go to the subject, we have flow diagrams here. What do you mean? You haven't checked the location. That's what happens here in the make move function. Does that not? Make move, make move, make move. If the coordinate has a line, then set the bit to revealed for the given coordinate, and then set the variable that tracks if the player has lost to an appropriate value. So the make move does do that. So you have checked if it has a location in the make move function, which is here on our diagram. And that happens, then we print, then we check the end of the game. Does that answer the question, or was this things? This checks it if you're trying to flag it. Okay, because remember you've got these three variables. If it's already a flag, we are checking if it has a mine, but we're not revealing it. We're just setting these variables, the game's flagged and the mine's flags. This isn't actually revealing anything at all. It shouldn't be revealing anything here. This is just flicking on. So let me go through the flow diagram quickly. Let's do an example. Let's do a quick example. Oh, some German stuff. So, blah, blah, blah. A good example. That's a very good example. I might just steal an example from myself. Where did these videos go? Silence. Actually, no, it's not. Okay, I'm not going to do that. I'm do something else. So I'm going to quickly draw up a board because it'll make it easier. What I do want to still have on is, how is it? So I'm actually going to draw up a board and we'll walk through it. So make this a fairly small board. So this is my board. Just get a bit darker. Okay, it's all good. So we have 1, 2, 3, 4, 5. So I'm not worrying about the hidden section at this stage. As we talked about, there's a hidden border. We don't really care about that at this stage. So at this stage, alive is 1. Shouldn't do that. Bad practice. So alive is 1. What am I doing? We have our game variable, and I'm not going to worry about all of its elements, but I'm going to worry about mine's flagged, and I'm going to worry about flags. Okay, so let's say this position has a mine, 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 this position has a mine. Okay, so we have a 1, we have 2, we have a 1, we have 2, we have a 1, we have a 1, we have a 1, we have a 1, no, we have a 2, sorry. 2, 3, 2, we have 1, 1, 1, 1, 1. We have 1, we have 1, 1, 1, 2, 3, 2, and 2. Okay, so let's say they're all unrevealed. Okay, and so the number of mines flagged at this stage is going to be 0. The number of flags is 0. But the number of mines is 5. Okay, so mines is 5. And that value doesn't change once it's set. So is alive equal to 1? Yes. Is game.minesFlagged equal to games flags? Yes, it is. And games flags equals games mine. No, it's not. Okay. So that's fine. We can keep going. Now, I was just about to show you before, that's obviously a do-while loop. If you look at the flowcharts, which you need for your exam, you can see the do-while loop. Basically, with flow diagrams, if you've got a condition that doesn't return to itself, that's an if. If you've got a condition that does return to itself, that can be a for loop or a while loop. And if you've got a condition that comes back into itself after something, then that's a do while loop. Okay. Then we call the getMove function. So let's say they enter 2, 2, 1. Okay. So we get that X, Y, it's uncovered, and it's not a flag. Okay, so that's fine. So it passes both of these. Is flag equal to 0? No, it's not. Okay, so we don't call the make move function. We go here. Location XY is already a flag. No, it's not already a flag. So we go over here. We set flag bit on that location. So now this is a flag. We increment the game flags. So this might actually help the other person who was asking about incrementing. Does location XY have a mine? No, it doesn't. So then we print the board. And we go back up. And then I get to this get move and I enter 2, 3, 1. Okay. So this location isn't uncovered. None of the locations are uncovered at this stage. So uncovered means unrevealed as well, if you didn't pick up. And it's not a flag, so that's fine. Is flag equal to 0? No, it's a 1. Is location already a flag? No, there's no flag there. So we can use that bitwise to work that out. Set flag for that location. Increment game flag, so we have a 2 here now. Does location XY have a mine? Yes, it does. So we increment mine's flagged as well. So we can see that the game ends when all of these are equal. Okay? Or you click on a mine. Now I'm going to click on a mine. So I'm going to go back. So I print the game, then I go back up. So now I'm going to go 1, 2, 0. Okay, so I'm going to click on this one. So we get the move. This is uncovered. It's not a flag, so I don't have to worry about that. Is flag equal to 0? Yes, it is equal to 0. So I go to this make move function. Okay. So where is the sun going? So we now go into the make move function. If the coordinate had a mine, set the appropriate bit to revealed. Okay, so give me a good color. Let's say red. So we set this to revealed. So this one is revealed. None of the other ones are revealed at this stage, even though we went down here and had a look at the mines. And set the variable that tracks the player to an appropriate value, which is obviously alive. Else, we're not doing any else here. Okay, so we can leave that. Damn it, that was on that layer. Yeah, I know, calm down, calm down. Then we leave this function, we print the game. So this is the only one that's revealed. So we should get a mine there and a whole heap of hashes around it. Okay. And then we get up here and we check is alive 1. No, it's not. So we keep going and we say, you lose. Okay. Does that make sense? Why do we lose so many people? Is that really that boring? Or if I go on, so we're just basically serious. Okay. So yes, the answer is yes, it does print the game before. And if you look at the test cases, every time I flag a mine, the game ends. That's called hacks. It's just cheating if the game ends and you hit a flag. Okay. So I had a question just on the chat about setting the variable. So create a global variable, which is type int and initialize to 1. This will track if the player has still not clicked on a mine. When selecting a mine, this will change to a 0 to indicate the game is over. So what would be an appropriate value to set the global variable when you hit a 0? I mean, not the demos, kind of, when you hit a mine. Okay, so if you go back up, that kind of gives you the answer. Now, if you're, every time I flag a mine, the game ends. So I would probably check this condition up here, if that's right, because this is the only way to get to the game's end. Okay, it's the only condition that lets you get down there. So either this is wrong, which would probably be the easiest fix, or you're setting these 4 values that it's dependent on wrong somewhere else because of the flag. So you've got 4 variables, sorry. You've got 4 variables here that could be wrong, or the condition could be wrong. Now, if it's the condition, that's easy. If it's one of these 4 variables, have a look everywhere you change those variables in the whole thingamajig. Structure, flowchart, whatever you want to call it. Does that answer the question? Okay, so if it's not the condition, then I'd be checking those 4 variables on where they get set, because the only way to get to the end of the game is through them. If that makes sense. Or it could be an initialization problem beforehand, that these aren't set to the right values, but I doubt that. Yes, this is another problem that I noticed a couple of people do, especially last year when I did the checkers game. So one thing that you should be aware of, and you need to be careful about, is, and there is a reason for this, and you would have seen this in this week's lab as well, but I introduced it fairly early on. This is the y variable, this is the x. So the first brace is always talking about the y, and the second is always talking about the x. Okay. So if you want to have a look at some solutions, there's, I don't know how many I put up there. There's a whole bunch of them on LMS, and there's the 2 videos there that go. So there's the example outputs. So if you go here, example outputs with and without the bonuses, and there's a whole lot of test cases as well. You can compare your answer with the test cases. Okay, and you can slow the video down however you like. Now, I can't really zoom much further without reducing the quality, but that's there for you to go through. And you should be able to check if you've inverted something there. Okay. Yeah. So I'll just repeat that. With the arrays, this is the y, this is the x. Okay. And you would have noticed in this week's lab, if you look through the documentation and have a look at the three-dimensional, the z is here. And there is a reason for that. There's actually a couple of reasons, but yeah, we don't have time to go through that right now. Okay, so given that it's 9 o'clock, I'm gonna have a quick break. And if there's more questions, it'd be great to see them. Okay. All right, who's still here? If you're here, please say hi in the chat. Something in the chat. Anything. Cats and dogs. No, stop moving around. There we go. Should go from this side. So just be careful with this x and y and the I and j. If you've got the for loops around the right way, the I and j should be I and j. If you've got the for loops in the wrong way, then they're going to be backwards. So just be careful with your x and y's. Okay. remember that you can debug and always print out your X and Y values. And once you're printing the board, you can clearly see where you're going to test if you're in the wrong coordinates. You can always test a spot on the board. Just pick a location. All right. Have you got any more questions? I wanted to also mention RAND. So this was another question that was asked by email a couple of days ago. And it's actually a really good question. It really doesn't affect anything because you're kind of given it. But and I did put a little note on LMS. So I might actually copy that across too. So we're using RAND. Okay. Now I'll explain these two lines. Now, because you've got an exam coming up, this side you should understand. RAND isn't part of the exam, I can tell you that. It wasn't something that was covered in the subject, and that's why this bit of code was given to you. But we do know that this gives us a random number. Well, a pseudo-random number. I can spell. So we have RAND. And all this does is gives us a random number. Now, just want to grab something. Okay. Okay, so RAND gives you a random number. Now it gives you an integer. So we'll give you a number from 0 to 3276 in most cases. Now you can actually change the top part. Didn't I already explain? Okay, I'm just going to re-go over one of the questions. I did already answer it, but I may have missed it. So one of the make move functions, if a coordinate has a mind, set the appropriate bit to revealed for the given coordinates and set the variable to tracks if the player has lost to an appropriate value. So the losing case is if you touch a mine. So if we go all the way back up to the top, somewhere here, create a global variable which is type int. This will track if the player has still not clicked on a mine. When selecting a mine, this will change to value 0 to indicate the game is over. Okay. So we can see what value to change it to, and we can see what variable it is. Okay, let's go back to RAND. Okay, now this is a pseudo-random number. So it's basically a function, usually a multiplication function, that will basically just give you a random number. Now, when using RAND, if we run it, it will always give the same combination of numbers. So let's say it gives 12, then it gives 362, then it gives 14, then it gives 87, then it gives 92, then it gives 108, and so on. Okay. Now, how we deal with this so that it doesn't always give the same numbers from the start is we seed rand. Okay. Now, in our assignment, we're not seeding. Okay, so if you're asking about seeding, do not seed. Okay. Because a couple of people have asked if they're allowed to seed rand, especially those that have finished early. We're not seeding rand. Okay, seeding rand means that we give it a random place to start in this sequence. So, for example, one time it might start here, or another time it might start a million digits later, or something like that. And so it means that we never get the same combination of numbers. All right. And we would have seen in the last lab that we did that rand was seeded. So it meant every time we ran it, we did get a different matrix. In our case, our rand isn't seeded, and so we'll get the same combination as long as we're using the same system. Now, I just wanted to quickly, because we have got an exam coming up, explain what's happening on this right-hand side. So we have the mod operator. It's expected that you know what that is. And then we have game dot height. Then we have +1. Now we remember that we want all the mines to be between 1 and game dot width and 1 and game dot height. So we want them to be in this center region. Okay. So if my game is 4 by 4, then we know we have a 6 times 6 matrix because we add the 2. So here what I'm doing is I'm going rand mod game dot height, meaning the remainder. So let's do an easier example. I'm going to go 10 by 10. So meaning it's a 12 by 12. So if I go 82 mod 10, it's going to leave a 2 as the remainder. If I go mod 10 here, it's going to give an 8 as a remainder. And so you can see that it's limiting the numbers between this. Now, we actually want our values to be from 1 to 10. This is only giving us numbers from 0 to 9. So we shift that across 1 by adding the 1 at the end. So we get numbers from 1 to 10. And that's all that them two lines are doing. But we are not seeding rand. Okay? So those that know about pseudo-random numbers, yeah. That's the answer to that question again. Right? Does that make sense? It means that we can test it and you can test yours against our cases because it's not fully random. Now there is obviously the fact that you're using the same system. If you're using another system, it won't always work this way. Does that make sense? Does that not make sense? No. Cool. Okay, so you don't need to know rand for the assignment, but you should know what the other parts are doing, especially the mod operator. So the mod operator, you may have seen in maths as remainder. Okay. And it's not the modulus, it's mod. Okay. Which does get a bit confusing for some people, just with the naming. Okay. Now, I just want to also talk about seg faults and debugging and why we use GDB and our box and pointer diagrams and sorry. Right. So seg faults and debugging, and I know a couple of students have got into a little bit of trouble here because two reasons: they refuse to draw box and pointer diagrams, or they refuse to use GDB. And there is also a bad way to debug, and I might actually show you. It's not like it will find your problem, but it's not the best way to go about debugging because it can actually be confusing as well. Also, we just got a question. So the mod operator, I lost it. So mod here stands for modular. I guess for that one. Okay. So modulo is the remainder. That's where the name comes from. All right, so seg faults and debugging. So let's say I've got a small program and I'm just going to go index star y equals the address of x. Now that should be fairly simple at this stage. I'm then going to go printf. Actually, I'm going to do this a little bit. And this is just something to be aware of. And it's a common trap that people fall into when using this debug, because debug is for debugging logic. It's not for debugging crashes, and it won't pick up a crash the way you think it does. And a lot of students try and use this debug to pick up crashes, and it's not going to work in most cases, just because how things are flushed to the screen. Seg fault before or after. And then down here, I intentionally seg fault. So I'm going to go, what should I do? I'm just going to go y, because this is a pointer, I can use the square brackets, even though it's not an array. And I'll put 2000 here, becomes 3. Okay, so this line is very likely to seg fault, okay? Because I'm obviously not meant to be there. This point is only pointing to one memory address, but I'm going 2000, well, 1990. 99 past it and trying to put a 3 in there. Now, my question to you is, will it print out segfault before or after? Or just, will it print out segfault? Let's make it simpler. Will it print this out? So the interesting thing is that it may or may not. And in most cases, it won't print this out. Even though this happens before the segfault, because the printfs are actually put onto a buffer and then flushed to the file, which is the screen. When you've got an executable, it might decide to do it after it's done a bunch of operations rather than do it before the operations. And it usually will wait till it needs to be flushed to optimize your code and its execution. And when you start having a look at I/O operations in the processor, which you're not expected to know now, I/O operations are generally slow, and so it will try and wait to a suitable time to use those. And so it's unlikely that you'll actually get this segfault printed before you segfault. Okay, and so this is why you shouldn't use debugging, this debugging macro and printf to do this. Now there are ways to get around this, so you can force a flush by using fflush. However, that's something we haven't covered, so that's not the best way to go about it. Now, there is one way, which I don't usually recommend, and if you can do it using box and pointer diagrams or GDB, that's usually better. But I'm going to do a quick example. So I'm going to set x equals 4. Then I'm going to call some function. So I'm going to call func2. I'm going to call func3. And I'm going to call func4. And then I'm going to return 0. Actually, no, I'm going to return 0. Okay. Now, at this stage in my program, I'm segfaulting. And I've worked out that I probably shouldn't really be using the debug macro to try and find this segfault. I'm going to try and get rid of this green thing. Cool. Okay. Now, I don't usually recommend this method. There are better ways to do it, and we haven't covered them, so I'm just going to show you this. But once you learn better methods, you can kind of stay away from it. So I know this program segfaults, okay, but I don't know where. Now I could use GDB and find out where, and that's probably the best way to do it. But if you really, really are stuck and you really want to find out where, what we can do is I can put a return 0 here. Now this doesn't find the fault, it just finds where it's segfaults. Okay, so you use the debugging to actually find out where the logic error is that causes the seg fault. But if you want to find out where it seg faults, that's another problem. And this is what we're trying to find, where it seg faults, not why. Okay? We're just trying to find where. Okay? The why, you need to use the debug macro. Okay, so I had a return 0 here, and it doesn't seg fault. Okay? So I know that where it's seg faulting is not up here. I then move this return 0 to here, and it still doesn't seg fault. Then I return 0 here, and it does seg fault. So which function is where it seg faults? And the answer to this, be careful with how you answer it. Okay. So we now know it does seg fault here. However, do we really know that? Because what if we were lucky and it just didn't find invalid memory last time? Okay, so you have to be careful using this method because maybe it is still seg faulting here randomly, 1 in 100 times. However, generally a lot of the mistakes you're using is because of malloc, and so if you are getting a seg fault, it's usually fairly repeatable. Okay, not all seg faults are repeatable. Okay, and that's why we use GDP or multiple test cases. So we can assume the seg fault is here, but it doesn't mean that it has to be here. It could sometimes be here as well, or up here as well, because seg faults happen when you're accessing illegal memory. Okay, so it sometimes may select an illegal spot and sometimes may not. So just be aware of that. This method can be helpful for given what you're doing right now, but it's a really bad method because it doesn't actually pick up much. But if you're doing something significant, it should pick up in most cases for something simple like this, where it's seg faults. It doesn't say why though. So the reason why might be in here, whereas where it's doing it is in here. Does that make sense? And this is why with seg faults, we need to be really careful, and generally it's always good to draw a memory diagram. Pick a standard case, so let's say a 3x3 board, to make sure you never walk outside of that area. And you can print indexes out to make sure you never walk outside the area. So I'm not going to go over the uncover zeros in more detail than I have, just because that's meant to be the question that tests the high end of the students, and we've already got 6 people solve it, and so I don't want to ruin their ability. So I've given some information on the uncover zeros already. The get moves pretty sure we already covered in the last times one, so I might actually just refer you to that one. Let me just see which one it was. So the uncover zeros is a recursion problem. I covered a little bit at the start of this and in the last help session, but in terms of the get move, I think I just want to double check something. So I'm just trying to find something. I think it's this one. Wow. Okay. So if you want to know about the get move, have a look at the Saturday, week 11 help session from about around about the 15-minute mark. Okay. And there's an explanation for that. I don't know, about half an hour. Okay. Because I've already covered it, I might just leave that there. Okay. So if you want to know about the get move, have a look at that. It's probably a bit easier. So it's Saturday, week 11, at around the 15-minute mark. Okay. Fair question there, but I don't understand it. Yes. So there are late submissions, but please don't do it. It's 5% per day. So if you submit 5 minutes late, it's still 5%. Please don't submit late. There's no reason that you should. This assignment's been out for 4 weeks, so you've had 4 weeks to do it. Please don't do it. It's not, you've had heaps of time to do this. And all the material's been available. If I enter 5 for the number of mines, I get 5 Fs on the board. So at the start of the game, you shouldn't be getting any Fs. So there's only 2 ways you can possibly do that, is if your status byte is wrong, and we talked about the status byte last week. No, we talked about the status byte on Wednesday this week, so if you want to look at that, that's in week 12, Wednesday. Or your print board function is wrong. Or you're printing something else out, which I don't know. So they're the kind of things that I would be thinking is wrong if you're printing Fs out rather than uncovered. It's kind of hard to say. You need to debug that. They're the kind of areas that I would be looking at though. Okay. More questions? Well, let's hope I didn't make a mistake. So what's different about your outputs? Well, firstly, are you using Unix to print out the outputs? Or are you using a different program? Is the first question I'd ask you. Answer that. Yes, so that's why. As I said on LMS, even though you're using a pseudo-random number generator, because it is not seeded, if you follow the steps correctly, you'll get the same output on the LAT CS5 machine. If you're using another development environment or another machine, your outputs are likely to be different when you test. So if you want the same outputs, you need to run it on LAT CS5. So I would be checking that. And that's purely because the RAND function is implemented differently. Does that make sense? So the starting point of RAND or the function itself may be different. Okay, so test on the LAT CS5. These are all run on the LAT CS5. So they should line up if you're using the same machine. But if you're using a different machine or a different compiler, you won't get the same results. Okay. All right, any other questions? All good, all good. All right. Other questions? I think. One other thing I want to mention is don't forget to look at the marking guide. It's fairly general, but you'll also notice that there's more points this time. I mean levels of points. So when we take marks off, it will go down smaller. Alright, so we've talked about the make move, that's all good. We've talked about the print board quite a few times, so that's pretty good. If you're not printing the numbers at the top and the side, I wouldn't worry too much. I'd do that last. I'd try and get this middle section working first, because that's more important. Okay. Another trick that a lot of students have been doing is setting everything to revealed so that they can see what's going on. Or printing two boards, a revealed version and a non-revealed version, so that they can see what's going on, which is quite smart. We have initialized mine values. I think most people have done that by now. Not done it, but done it quite early on. This is the bit manipulation one, which we've talked about in previous videos quite heavily. So you can look at those, especially last week's one was quite helpful, I think. Wednesday's one this week was quite helpful with that, plus the weeks before. We have initialized mine board. We have this big thing, which, considering this is in your exam, I'm expecting you yes, I've checked my email. I'll talk about that in a sec. I don't really know the answers to that. We have mine board. I think most of it did this week's ago. And we have all this stuff up here. So I don't think there's anything that we haven't covered. You all know how to use the debug macro. You all know how to use GDB. You all know how to use box and pointer diagrams, even though a lot of people refuse to use them. And you all should know how to do flowcharts by now. So there's not much left. The only thing is the uncover zeros, which we want to make sure we don't give too much information away about, because we want to make sure we're rewarding students fairly. Right. Now, okay. So I just want to see. Okay. So just in terms of the question that got asked, usually this happens from copying and pasting it from Unix to Windows and Windows to Unix. There's different characters used on different systems. And this is usually seen when people copy from Microsoft Word or something like that code. You end up with all these stray characters. I might just talk to you about that outside of this. Get that fixed. Right, other questions? All right. What might do then? We'll all right, let's do some revision then. If there's no more questions regarding the assignment. One other thing, we all signed up to the help sessions next week. So I set up a bunch of exam prep sessions next week. Ideally, come to the Tuesday one. That's going to be the big one. And then go to another one. If you can't, you can't. But Tuesday's going to be the best one to attend. If you can. I did set up so you can attend. There's still heaps of places for Tuesday, so you can attend Tuesday and another one. There's still 50 spaces there. All right. So what we might do? Let's grab some questions. Do some revision. Or what I might actually do is, which I kind of wanted to talk to you about last week, but I kind of got sidetracked. And that is this whole thing, which is the bitwise operators and how they work. Now, I did do this a long time ago, but considering I've got an exam coming up, it would be good to review this because it is very handy in understanding why we use these common operations. So what I'm going to do is get this up and then explain how each one works, because you should be able to do this